to graph with a vertical shift and a horizontal shift polynomial functions. So to graph a normal kind of graph with just a slight change, multiplication of the parent graph, all you do is make an xy table and you plug in 3 points for x. So I plug in 0, 1, negative 1, and so if you plug in 0, you plug it into the equation 2x to the fourth. You plug in that for 0 for x, you're going to get 0 for y. You plug in 1 for x, you're going to get 2 for y. You plug in negative 1 for x, you're going to get 2 again for y. And the graph will look something like this when you've done, after you put each of these points in the graph. For an odd digit multiplicity, you're going to have multiplicity, you're going to have a graph that looks a little different. So if you plug in 0, 1, and negative 1 again, you're going to get 0, 2, instead of 2 for the type of the top, you're going to get negative 2, and your graph's kind of going to cut through, instead of making this U shape like it did up here, it's going to cut through the graph kind of like this, and the bigger the multiplicity, if it's greater than 1, it's going to get wider, and if it's less, or it's going to tighten up. If your multiplicity, if your coefficient is bigger than 1, it's going to get smaller, your graph, so when U is going to get smaller, and this is going to get closer together. And if it's less than 1, it's going to get wider, and it's going to be more far apart. For vertical shifts, it's, for example, in the equation f of x equals negative x. For vertical shifts, it's, for example, in the equation f of x equals negative x to the fourth plus 2. You're going to plug in, you're going to do the exact same thing with an xy table. You're going to plug in 0, 1, and negative 1 again for the same equation. This time you're going to get 2, 1, and 1. So what's going to happen is the graph, instead of starting at the origin like it did over here, it's going to start 2 places up because of the plus 2 of where it started, of the origin on the y-axis. And also because it's a negative x, the whole graph is going to flip around. So it's not going to be facing upward, it's going to be facing downward. But it's the same exact concept where it's still going to be a U shape because it's an even multiplicity, an even power. Plugging 0, 1, and negative 1, and you're going to get 2, 1, and 3 for your y's. And it's going to, again, the whole graph is going to shift up to, it's the same graph is over here, but it's backwards again because it's negative, and everything is up to. So, horizontal shift. What's that? Pause on that. Alright, so here's the horizontal shift. It's basically just really just shifting over whatever x amount of points to the left or the right on the x-axis. So we do the same exact thing we did for the other two. You just plug in points again. So you plug 0, 1, negative 1, 2, and you get 1, 0, 16, and 1. And so if you look at the graph, it's going to look something like this. The real trick to it is if it's x, whatever's in parentheses, if it's x minus 1, you're going to go over to the right one. And if it's x plus 1, you're going to go back 1. The point you start at, the changing point, is going to switch over whatever your other value is. So it's not as hard as it looks in this case. So it's the same thing for an odd power. You have 0, negative. So it's the same thing for an odd power. You have 0, negative 1, 1, 0, negative 1, negative 8, 2, 1, 3, 8. We get more points this time. And you're going to get the same kind of graph as you would get any other odd power, the same shape of graph, but it's going to look, everything's going to be shifted over to the right 1 because it's x minus 1 in parentheses to the third. If it was x plus 1, this point would be right over here. Yeah, so that's about it. That's how you plot polynomial functions.